You know the exact feeling. You're exploring a meticulously crafted fantasy village in an RPG, and you accidentally, or let's be honest, completely on purpose, swing your broadsword at a local merchant.
Oh, yeah, classic.
Right, maybe you knock over their cart, steal their prized healing potions, and just cause absolute unmitigated chaos in the town square.
And then you run away.
Exactly. You run away, wait about 2 minutes, and walk right back up to that exact same merchant. And what do? They look you dead in the eye and say, "Greetings, weary traveler. Care to browse my wares?" You didn't just ruin their entire livelihood.
It completely shatters the illusion. I mean, the graphics might be photorealistic, the physics engine might calculate the exact trajectory of every spilled apple from that cart, but the world itself has the memory span of a goldfish.
Goldfish memory. That's the perfect term for it. And it's wild because current game AI can generate incredibly realistic dialogue in the moment.
Yeah, very dynamic.
You talk to an NPC, and they sound completely human. But structurally, under the hood, they're operating in a total vacuum. Every single interaction is a first date.
Right.
But today, we are taking a deep dive into a completely new architectural approach that is trying to fix this exact broken plumbing. It's called collapse-aware AI, or CAI.
And we are looking at a fundamental shift here. The mission of this architecture isn't just to make NPCs sound, a little less robotic.
Or to build sassy, stateless chatbots.
Exactly. It's about building genuinely emergent, evolving digital worlds that actually remember what you do and, more importantly, change their behavior based on those memories.
To figure out how they're pulling this off, we've dug through a massive stack of developer materials. We're talking about an operational architecture record published on Zenodo.
Version 2.1 specifically.
Yep, version 2.1, alongside a public proof pack that was dropped straight onto GitHub. We're also pulling from some public-safe architecture overviews from Inappropriate Media Limited and a really fascinating, almost philosophical Substack post by the creator of the architecture, Marcos Varela Moss-Ross.
The overarching theme across all these documents is infrastructure. I mean, this isn't a clever new prompting technique where you just tell the AI to act like a grumpy merchant.
Right, it's deeper than that.
Much deeper. The materials outline a structural rewiring of how artificial intelligence integrates with persistent digital environments. They are changing the foundation.
Okay, so let's unpack this. Before we look at the shiny new features CAI brings to the table, we need to understand the structural flaw it's actually fixing.
Which is pretty massive.
Yeah.
Okay.
According to the architecture overview, the current standard for game AI treats generating behavior as a one-step problem. You press a button to talk to an NPC, the AI generates a response, and it hands that text straight back to the game engine to display on your screen.
Which is a brilliant party trick if you are just, building a standalone tech demo. But in a persistent 60-hour game world, that one-step process is incredibly fragile.
Because it just hallucinates.
Well, the developer documents describe how this one-step method inevitably leads to unpredictable behavioral drift. The characters are highly reset-prone. Because there is no behavioral continuity, the AI might decide the merchant is terrified of you in one sentence and then offer you a discount in the next.
Wow.
Yeah, it just spits out the first statistically likely string of words it calculates.
That's like having an overly eager improv actor on a stage. You throw them a prompt, and they instantly pitch the first wild idea that comes into their head.
That's a great way to put it.
And CAI's solution is to fundamentally change that dynamic by separating the generation of an idea from the selection of that idea. It introduces a middleware layer.
Right. It sits right in the middle.
Exactly, between the game's application layer and the final output that you see on screen. So if the base AI is that overly eager improv actor pitching 10 different lines for a scene, CAI is the strict director who actually evaluates all those options and chooses the single line that fits the long-term story of the play.
That is the exact function of the module they call the crown selector. In this architecture, the base AI model, your improv actor, still does its job. It generates a bounded set of candidate paths.
Like maybe 5 different ways an NPC might react to you stealing a potion.
Exactly. But the base model doesn't get to make the final call. The crown module is a sealed decision core sitting in that middleware space. It intercepts those 5 candidate behaviors, scores every single one of them mathematically, and decides which one actually becomes the system output.
And the creators call this process collapse.
All right.
Collapse, that sounds like a physics term. What exactly is collapsing in a video game?
Well, in this context, they define collapse very specifically as the governed selection of one candidate behavioral output from a bounded set. The AI dreams up a realm of possibilities, and the crown selector mathematically collapses all those possibilities down into a single concrete reality.
And it makes that choice by scoring the options against three canonical signals, which are recency, salience, and anchors.
Yes, those are the three core metrics.
I want to put this into a concrete scenario to see how this math actually fights itself in real time.
Mm.
Let's go back to my favorite hobby-tormenting digital merchants.
Naturally.
I'll walk up to a shopkeeper, and instead of buying a potion, I draw my broadsword and point it at his face.
Mm.
The AI generates 5 possible reactions. How does the crown selector use those 3 signals to pick the winner?
It starts with recency. This system looks at temporal proximity. Drawing a sword is something that happened 1 second ago, so it carries a massive weight.
Makes sense.
Recency dictates that the immediate action, the threat, needs to be addressed right now. So candidates where the merchant ignores the sword and talks about the weather get a terrible score and are immediately discarded.
That is perfectly logical. But recency alone isn't enough, which brings us to the second signal, salience. This basically asks what actually matters.
Right, salience measures emotional weight or gameplay significance. Dropping an apple is recent, but drawing a deadly weapon is highly salient. It is a life or death moment.
So the math heavily favors the candidate behavior where the merchant screams, cowers in fear, or calls for the guards.
Exactly. The salient score pushes the system toward a drastic reaction.
But here's where the third signal anchors comes in and completely changes the game. The documents describe anchors as stable reference points that preserve identity, tone, and long-term objectives.
They're the core of the character.
Yeah. So what if my shopkeeper isn't just a random peasant? What if the developer planted an anchor in his profile stating he is secretly a retired, highly lethal assassin hiding out in this village?
That is where the collapse gets fascinating. Recency says, respond to the sword. Salience says, this is a deadly threat. But the anchor score overrules the generic cower in fear response.
Because assassins don't panic?
Right. The anchor insists that this specific character does not panic. So the crown selector evaluates the remaining options, the candidate behavior collapses, and instead of screaming for the guards, the merchant calmly pulls a poisoned dagger from under the counter and tells you to put the toy away.
Oh man. The math literally forces the character to stay in character.
Exactly.
And to keep all of this from going completely off the rails, there's a fourth element in the formula called the governor. This is essentially a stability control layer.
Yeah, a safeguard.
I imagine its entire job is to be the ultimate safety net, dampening unstable drift. So our retired assassin doesn't suddenly start reciting Shakespeare while holding the dagger.
The governor blocks chaotic paths. So if you look at the actual mathematical sketch provided in the Zenodo record, the formula is remarkably straightforward. Every candidate behavior gets a score.
Let's hear the math.
That score equals the recency influence, plus the salience influence, plus the anchor alignment, plus the governor's constraints, minus any penalties for being a poor fit. The highest score wins.
It is literally grading the AI's internal monologue and picking the valedictorian.
Pretty much.
But what I really appreciate about these sources is how carefully the creators frame this. They explicitly state in the public documentation that these numbers are just there to express selection logic. They're actively avoiding that overly hyped Silicon Valley marketing where everyone claims their AI is suddenly sentient.
What's fascinating here is they're very firm on that point. This is not a claim of magical consciousness. It is simply controlled continuity. It's applied mathematics designed to make runtime behavior believable and stable. They are building a better puppet string system, not a real boy.
Okay, that math works beautifully for the next 10 seconds of gameplay. It stops the AI from hallucinating a weird response to my drawn sword. But what happens tomorrow?
That's the big question.
Right. If I leave the village, go clear out a dungeon, and come back a week later, that simple math score from the sword incident has evaporated. Recency is gone. How does the merchant remember me? Because a momentary math filter doesn't equal long-term memory.
That limitation is exactly what drives the philosophical framework behind this entire project, something the creator refers to as Varel's law.
Varel's law.
Yes. It proposes that time, memory, and emergent behavior do not come from stateless computation. They arise from memory-weighted informational collapse.
In plain English.
In plain terms, memory isn't just a dusty filing cabinet you occasionally open to check a fact. Memory is a heavy weight that actively biases whatever you decide to do next.
Which leads us directly into what the developer documents call Phase 2 of the CAAI architecture. And this introduces a concept that sounds incredibly dense, the connectivity topology layer, or CTL.
It sounds intimidating, but the CTL is where we move from basic moment-to-moment signal scoring into deep, long-term probabilistic modeling. It represents every active contextual element in memory as a stimulus-conditioned weighted graph.
Let's extend our earlier metaphor. If the Phase 1 crown selector is the strict director choosing the improv actor's lines on stage, Phase 2 is that same director sitting in an office with a massive red string detective board.
Oh, I like that.
The nodes on the board are the player, the town, the hidden dagger, the past threat. The strings connecting them show how recently they interacted and how salient that interaction was.
That red string board is the perfect visualization of a topology graph. The edges, the strings, are associative links.
Here's where it gets really interesting, though. I have to push back here, because anyone who has messed around with AI recently is going to ask the obvious question. We already have AI context windows that can hold entire books of text. Why are they building this massive, complicated red string detective board? Why not just stuff the AI's context window with a massive transcript of everything the player has ever done? Just feed the NPC the raw text chat log and tell it to read the log before it speaks.
The creators actually anticipate that exact argument in the GitHub repository. There's a document in the proof pack specifically titled Phase 2 Memory, Why Not Full Context?
And what's their defense?
The fundamental problem with just stuffing a massive transcript into a context window is that raw text doesn't provide structured behavioral bias.
What do you mean by bias in this context?
Well, when an AI model just reads a huge list of past events, it treats them all relatively equally. Or worse, it suffers from lost in the middle syndrome.
Oh, where it vividly remembers the very first thing you did and the very last thing you did, but completely forgets the 30 hours of gameplay in the middle.
Exactly. Transcript stuffing gives the AI raw data, but it doesn't tell the AI how much that data should matter.
Oh, so the AI might read the log and know that I threatened the merchant a week ago, but the raw text doesn't tell the AI how to feel about it, behaviorally speaking. Doesn't know if the merchant got over it or if he's been stewing in anger for 7 days.
Precisely. Transcript stuffing doesn't provide stability or realistic grudges. CAAI is intentionally designed not to rely on larger context windows or constantly retraining the base model. Instead, it uses Bayesian posterior weighting to update the graph.
Bayesian posterior weighting. Let's translate that for those of us who didn't major in statistics.
Fair enough. Think of Bayesian weighting as a mathematical way of updating your prejudices or assumptions based on new evidence. The system starts with a prior and existing assumption about the world.
Like the merchant assuming I'm a threat.
Exactly. Let's say the merchant's prior is that you are a dangerous lunatic because of the sword incident. Then, the system looks at the likelihood how well a new candidate behavior fits the...
And the sources talk about a mechanism driving this called emotional gain, which, I'm not going to lie, sounds like we are drifting right back into that sci-fi, the AI has feelings territory.
The technical record is quick to shut that assumption down. Emotional gain does not refer to literal human emotion.
Okay, good.
Yeah, it's an internal math multiplier. It's a modifier derived from markers that act as proxies for human effect.
Proxies like what?
Things like detecting a sudden tone shift in your dialogue choices, a contradiction in your story, urgency in your movements, or simply repetition.
Oh, repetition is a big one.
Think about a player who walks up to an NPC and asks the exact same lore question 5 times in a row to see if the dialogue changes. Every time they repeat the prompt, the repetition marker increases the emotional gain number.
Which feeds back into the math.
Right. That number changes the math in the connectivity topology layer, which alters the likelihood of certain polite behaviors being selected by the crown. The NPC doesn't actually feel annoyed, but the math replicates annoyance by collapsing the candidate pool down to snappy, dismissive responses.
Wow. Forget the Bayesian math for a second. Think about what this actually does to your Saturday night gaming session. Because the Substack post paints a picture of a totally different kind of player experience. It moves away from treating NPCs as vending machines for quests and turns them into reactive elements of an ecosystem.
The creator makes a brilliant point of contrast in the Substack. They mention a recent release from Logitech called the Intelligent Gaming Agent. Now, that is a highly marketed AI tool that sits on top of a game.
Right, on top.
It helps streamers run audience polls, it manages the Twitch chat, it might even optimize your streaming software, but the video game underneath remains completely unchanged.
The Logitech tool is basically a really smart butler entertaining your audience.
Yeah.
But the author points out that CAI is fundamentally different because it sits underneath the floorboards. It's a background engine that transforms the gameplay itself.
Exactly.
While other AI tools are busy managing the chat, CAI is fundamentally reshaping the physical and social world you are walking through.
And the Substack gives us vivid examples of what this looks like in practice. They talk about NPCs possessing memory echoes. Because the system doesn't rely on querying massive, slow databases every time you speak, characters can retain these lightweight memory anchors and bias their future choices naturally.
Like holding on to a favor.
Yeah. If you heal a wounded scout in the woods during the tutorial, that memory echo becomes a permanent anchor in their behavioral graph. 40 hours later, they might intervene to save you, not because a writer hard-coded a scripted event, but because their topology graph mathematically drove them to that specific behavior.
My absolute favorite example they give isn't even about a person. It's environmental. They note that if you decide to burn a forest down in a game powered by CAI, the eventual regrowth of those trees isn't just a random, procedurally generated event. The environment itself retains imprints.
That part is incredible.
Isn't it? The new growth carries the echoes of that past destruction. Maybe the wildlife that returns is more aggressive, or the types of flora that bloom are different. The world itself holds on to the history of your chaotic choices.
Which culminates in the ultimate goal of the architecture, stated plainly in the post. The world itself becomes a player. You aren't just interacting with a static, painted backdrop. You aren't being railroaded into pre-written story arcs by a team of narrative designers. The story emerges dynamically from this massive, interconnected field of memory and mathematical bias.
It is the difference between riding a scripted theme park ride, where the animatronic pirates reset to their starting positions the second your boat floats past, versus walking into a living, breathing ecosystem that actually holds grudges, remembers favors, and scars when you damage it. It makes your actions matter in a way that traditional, hand-coded game design just cannot scale to accommodate.
But this brings up the most critical question of the deep dive. Everything we have unpacked so far, Bayesian weighting, memory echoes, the red string topology graphs, emergent narrative, it is incredibly easy for that to sound like a theoretical white paper.
It sounds like magic.
Right. It sounds like a bunch of developers sketching big ideas on a whiteboard that will never actually see the light of day.
Which is why the GitHub proof pack and the Zenodo record are so important. They make it undeniably clear this is not theoretical vaporware. As of March 2026, they are actively running what they call the Phase 1.5 integration build. This is a functional, operational software architecture right now.
The way they've engineered this integration is incredibly smart. They use what they call a gold build scaffold. At the boundary layer of the software, they built a Flask API. The entire purpose of this API is to keep the outer contract stable.
Let's break that down for the non-developers. They use a Flask API layer. Think of it as a universal translator. The game engine, whether it's Unity or Unreal, speaks its normal, everyday language. The Flask API takes that language and translates it into the complex Bayesian math that CAI needs to function.
Exactly. And that means the crown module, that core intelligence selector doing all the heavy lifting, remains internally sealed as a black box. The game developers at a studio do not need to understand how Bayesian posterior weighting works. They just plug their game into the API using what the documents call a thin adapter.
So a game studio doesn't have to rip out their entire user interface, or scrap 3 years of coding, or rewrite their external APIs to make this AI brain work. They just attach the thin adapter, and the translation happens automatically.
If we connect this to the bigger picture, this modularity is a massive paradigm shift for the gaming industry. It means a sprawling AAA studio building the next massive open-world RPG, or an indie developer working out of their bedroom on a passion project can both license this middleware and plug it directly into their existing engines.
They get the benefit of a fully emergent, memory-driven AI system without having to build it from scratch.
And without breaking their game's existing architecture.
It's plug-and-play consequence. And they are so confident in this architecture that they built a bias-disabled mode directly into the integration build. The documentation notes this is specifically so reviewers or skeptical developers can compare the standard deterministic goldfish baseline against the CAI-enhanced behavior.
It's a great feature.
You can literally hit a toggle switch to turn the memory and consequence on and off just to see the stark difference it makes in real time.
It is the ultimate show-don't-tell engineering choice. You can boot up the test environment, draw your sword on the merchant with the bias engine turned off, and watch him act like a blank slate.
And then,
Then you flip the switch, the phase 2 topology graph engages, and you watch his behavior instantly collapse into a choice that respects the violent history of your interaction. It proves they aren't hiding behind smoke and mirrors. The math works.
so synthesizing everything we've pulled from these leaks and records today, collapse-aware AI represents a profound rewiring of digital reality. By acting as a mathematical middleware filter, it catches the raw, chaotic, one-step text generation of a base AI model and forces it to stop. It runs that eager actor through a gauntlet of recency, salience, and behavioral anchors.
And the result is a localized output that actually respects the history of the world it lives in.
Which brings us back to you, the listener.
Exactly. Because this matters deeply for you, regardless of your technical background. Whether you are a hardcore gamer tired of broken immersion, a developer looking at the future of engine architecture, or just someone observing the broader AI revolution from the sidelines.
It changes everything.
It really does. What you are witnessing in these architecture documents is the end of stateless digital interactions.
Yeah.
We are moving away from systems that forget us the moment we look away, and we are entering an era of true digital consequence. The systems will remember you.
It fundamentally changes our relationship with the digital spaces we inhabit, which leaves me with the final thought to mull over, building on that concept of the world as a player. If a digital environment really can remember your actions, if it mathematically weighs them through affect proxy markers, and if it evolves its entire physical and social topology based on your chaotic choices, at what point does the game world stop being a mere painted backdrop for your adventure and start becoming the main protagonist itself?